chapter of mathematics, let me just have a look at the syllabus first of all.
Yes, ma'am.
So, did you study any of the chapter before for 8th standard?
Rational numbers I studied, ma'am.
Okay, you have studied rational numbers. So, we have rational numbers, then we have linear equations, we have
In
quadrilateral,
one visit.
data handling. So, you studied rational numbers out of these, right?
Yes, ma'am.
Okay. So, shall I start teaching you rational numbers only, or shall I start with linear equations? What do you want?
You can start with rational numbers, ma'am.
Okay, rational numbers would be good. All right. So, we shall be starting with rational numbers only in this class. So, do you have any idea, Pavan, what are rational numbers? What do you understand by
Ra-
them?
Rational numbers are in the form of P by Q, where uh, P and Q are integers and Q is not equal to 0.
Oh, very good definition. You have given a proper definition. Good. So, rational numbers are basically, you also call them fractional numbers. Okay, why do you call
Yes,
them
ma'am.
fractional numbers? Because they are written in the form of fraction with a numerator as
Yes,
well
ma'am.
as a denominator. So, talking about rational numbers, they're written in the form of P upon Q. Very good. Just 1 second. Okay, so Pavan, please look on the screen. Now, if I talk about, first of all, we are studying rational numbers in this lesson. Now, if I draw a number line, so do you know that on the number line we have a 0? And to the right side of 0, that means as I proceed towards right, as I keep on counting after 0, I have 1, then I have 2, then I have 3, 4, 5, 6, and so on. And similarly, if I go towards the left hand side of 0, I will have -1, -2, -3, -4, -5, and so on. Right? So basically, towards the right hand side of 0, I have all the positive numbers. But if I go towards the left hand side of 0, then I have all negative numbers. Right? Now what do I have? If I talk about the numbers starting from 1, okay, if I will count all these numbers starting from 1, then what are these numbers known as? These numbers are known as natural numbers. What do I call them?
Natural numbers.
Natural numbers. Okay, but what if I start my counting from 0? I'm counting from 0,
From
1.
0, they are whole numbers.
Very good, Pavan. From 0, if you're going to count, then they are known as whole numbers. Okay? Whole numbers. Then, talking about the negative numbers also. That means now I have a set of negative numbers, 0 and the positive numbers. So, if I'm going to count all of these numbers together, then do you know what are they known as?
They are known as integers.
Very nice. Then they are known as integers. So, what are integers? Integers is a set of all the negative numbers, 0 and positive number. Then it is known as integer. Now you would say, okay, that is fine, but where are rational numbers on this number line? I gave you an outlook of a number line. So where does rational numbers lie on this number line?
1 minute, ma'am. I'll come.
Yeah, sure.
Yes, ma'am.
All right. So I was asking you a question that I gave you an outlook of a number line. How does the number line look like? But where does rational numbers lie on this number line? I know the place of every number now. I know positive numbers are going to be towards the right side, the negative numbers are going towards the left side of 0, then what are whole numbers where they are going to lie? Integers are all over the number line. So where are rational numbers basically?
I don't know, ma'am.
Okay, so rational numbers are going to lie between the integers. Okay, between the integers, you have rational numbers. So what are integers? For example, I have 0 and 1. So between 0 and 1, I can have various numbers between 0 and 1. Okay, like exactly in between 0 and 1, what do I have? What do I have? 1 by 2.
0. Yes, ma'am.
1 second. If I have exactly between 0 and 1, I am going to have a number which is 1 by 2. So 1 by 2 is fraction. It lies between 0 and 1, and 1 by 2, I know it is a rational number. Now similarly between 2 and 1, what I am going to have is 3 by 2. I will
Okay,
have
ma'am.
3 by 2. Then between 3 and 2, I will have 5 by 2. Similarly, then I'll have 7 by 2. Then I'll have 9 by 2 and so on. Now, if I talk about the numbers towards the left hand side again, between -1 and -2, I'm going to have -3 by 2. Between -2 and -3, I'm going to have -5 by 2.
-5 by 2.
Yeah, then I'm going to have -7 by 2, -9 by 2, -11 by 2, and so on. Right. So, what is the position of rational numbers? Now I know that rational numbers, what is its position? They lie between
Lie between integers.
integers. Very good. So, is this thing clear to you, the position of rational numbers?
Yes, ma'am.
Okay. Now we shall be talking about some of the properties of rational numbers. Let me just check in your syllabus what all properties you have. You have the closure property. Then you have the commutative law. You have associative and the distributive. Okay, fine. So the first property that is there in your syllabus is the closure property. Okay, now do you know what is the meaning of closure property?
It means like, can I tell for like which one should I tell for, ma'am? Like whole numbers, not small
Okay, tell me
numbers.
for whole numbers.
Okay, whole numbers. The sum of two numbers is always equal to a number.
What number?
It is equal to a whole number.
Okay, so like first of all, I have whole numbers. Okay, we studied what are whole numbers. We studied then the numbers starting from 0 and all the positive numbers apart from 0 along with 0 are known as whole numbers. For example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and till infinite. So if I talk
Yes,
about
ma'am.
any two whole numbers, let's suppose any two whole numbers A and B. Okay, I have any two whole numbers. Now A and B can be 1, 2, 3, 4, anything. Let's suppose, for example, I have 3 and 5. Okay. So Pavan, tell me, is 3 a whole number? Yes. Is 5
Yes,
a
ma'am.
whole number? Yes.
Yes, ma'am.
What if I add 3 and 5? What do I get?
8.
8. Okay.
8.
8
Which
as
is
a whole
also
number.
a whole number.
That's also a whole number. So what am I trying to tell you by this property is that whenever you have two whole numbers A and B, and if you add them, so it is going to give you a certain answer, and that answer is also going to be a whole number. Okay? Is this
Yes,
thing
ma'am.
clear to you? Easy?
Yes, ma'am.
Okay.
Yes, ma'am.
Now tell me one thing. This is the closure property for whole numbers, but I'm talking about addition. Okay. Let's talk about subtraction also.
Okay, ma'am.
I have two whole numbers, again A and B, and I subtract them. For example, I have, let's suppose 7 and 2. Okay. Let's subtract 7 and 2. So what is 7 minus 2?
5.
5. Okay. I know 7 is a whole number, 2 is also a whole number, and 5 is also a whole number. So you would say that, okay, ma'am, subtraction also follows the closure property for whole numbers. But if I change the numbers now, I take another example. Now I take, let's suppose, 10 and 15. Okay. Now when I subtract 10 and 15, what is my answer now?
-5. It is not. It is an integer. It's
It
not
is
a
an
whole number.
integer, but not a whole number. So 10 is a whole number, I know. 15 is a whole number, but -5 here is not a whole number. Okay. So what does this tell me? This tell me that closure property is followed by whole numbers for addition. But is it followed for subtraction also?
No, ma'am.
No. So addition, you're going to say for whole numbers you're talking about. So for whole numbers, this is true. That if A is a whole number, B is a whole number, then C is also a whole number. But it is not true for, you can just true for addition. Okay. Not true for
But subtraction.
subtraction. Are these 2 points clear to you?
Yes, ma'am.
Okay. So these are the properties. First of all, we'll also be talking about multiplication and division later on in the chapter. Okay, but first part of the chapter deals with addition and subtraction. So that is what I'm talking about, right? So first was whole numbers. The next in your syllabus, you have integers. Okay, you have for multiplication and division also right now. Okay. Let's
Yes, ma'am.
for multiplication and okay, so this is the first point. This was for addition. Then the second point was for subtraction. Let's talk about multiplication and division. Okay, so let's suppose again I have two numbers, whole numbers. Give me example of any two whole numbers.
10, 15.
10 and
8.
15. 8, okay. So let's try to multiply 10 and 8. So 10 multiplied with 8 would give me 80. Now again, I
Yes,
know
ma'am.
10 is a whole number, 8 is a whole number. It's giving me a whole number on multiplication. That means, does it follow the closure property? Yes. It is following the closure property, right? Now talking about division, do you think that division is going to follow the closure property?
No, ma'am.
Why no?
Because sometimes it can be decimals also.
Sometimes it can give you decimal answers also. It's not always true. It can be true, it cannot be true. Okay, so
Yes, ma'am.
the proof that we are talking about, it we are going to say that the particular algorithm follows that property only when all the answers will be true. So the case when some are true and some are not true, that does not follow up. All our answers should be true only. Do you understand this?
Yes, ma'am. Yes, ma'am.
So for division also, I can take examples like when I have 10 divided by 2. So 10 divided by 2 will give me 5, very easy. But what if I do the
Yes,
reverse
ma'am.
thing? I do 2 divided by 10. Now this is going to give me 1 by 5. 1 by 5 is
Yes,
not
ma'am.
a whole number. So it is not
Yes, ma'am.
for division. So now let's revise. I have closure property. So closure property for whole numbers. For whole numbers, addition and multiplication will be following the closure property, but subtraction and division does not follow the closure property. Clear?
Yes, ma'am. Yes, ma'am.
Okay. Next set of numbers are integers. Again, for integers also, we have four sets. We have for addition, then we have for subtraction.
Then multiplication and division.
Yeah. Now let's look at the examples of these also. Now, integers I know are negative numbers, positive numbers along with zero. They are known as integers. We devised the definition of it. So, talking about addition, let's take example of any two integers. Let's talk about -2 and +6. Any two random numbers I've taken. So, if I have
Okay,
a
ma'am.
negative number and a positive number, if I add them, so -2 plus 6, what would it give me, Pavan?
4.
4. Very
4.
good. A +4 would be my answer. Okay. So, this was one example. Let's take two negative numbers only. So when I have two negative numbers, let's take minus 4 added to minus 3. So what does this give me now? Two negative numbers?
-7.
Very good. It gives you minus 7. So you have minus 7. Okay, let's take two positive numbers only now. So plus 5 added to plus 4, let's suppose. So what does this give me?
9
9
plus
plus
9.
9. Okay, so I took various examples. These are all the possible examples that I can have. I can have a negative positive number. I can have two negative numbers. I can have two positive numbers. So all the time, am I getting an integer only?
Yes, ma'am.
I do get an integer all the time. So does addition follows the closure property for integers?
Yes, ma'am.
Yes, it does follow. So for addition, you're going to say yes, it does follow. Okay, talking about subtraction now. If I have two numbers, let's suppose negative 5 and negative, let's take two positive numbers first. Let's take plus 10 minus plus 7. I subtracted two positive numbers, 10 and 7 I am subtracting. So I get 3. So it's an integer
Yes,
only.
ma'am.
Let's take two negative numbers now. So I have, let's suppose, minus 5 and I'm subtracting minus 2 from it. So what does this give me? Two negative signs together would be a positive sign.
-3.
No,
-3.
minus
-3.
3. Very good. It will give you minus 3. So now again you have a integer only. Let's take one positive, one negative number. So I have, let's suppose, minus 3 subtracted from positive 1. What does this give you?
-4.
Minus 4. Very good. So now again, every time I'm getting an integer only?
Yes, ma'am.
Yes, I do get an integer every time. So does subtraction follows the closure property for
Yes, ma'am.
integer? Yes, it does. Okay, talking about multiplication, let's take any two numbers, 7 into minus 2. It gives you minus 14. Minus
Yes, ma'am.
3 into minus 7. It gives you positive 21. Then plus 2 multiplied with plus 6. It gives you 12. Again, I'm getting all integers. So multiplication follows the closure property.
Yes, ma'am.
Yes, it does. Then you have what? Division. Tell me for division.
Division 10 -10 divided by 2 gives -5.
10 minus 10,
Min
how come? Just take one number. Tell me for division once again.
-10 divided by 2.
Divided by 2. Okay. So what does this give you?
-5.
Minus 5. Okay. So this is following the closure law. That's correct.
Yes, ma'am.
But does it follow every time? This is one example. Can I
No,
have
ma'am.
can I have examples like the previous example I took? 2 divided by 5 only. So what do I have? 2 by 5. So
Yes,
2
ma'am.
by 5 is not an integer. It is what kind of number?
Um, Rational number or fraction.
Yeah, it's a fraction or a rational number. So does division follows the closure property for integers? No.
No, ma'am.
Okay. So we will just quickly revise. We are studying the closure property. So what does the closure property states first of all? The closure property states that if you have two numbers, whatever operation you are performing on them, the answer should be a similar pattern of number only. Okay. So for example, if you have two whole numbers, if you're adding two whole numbers, answer should be whole number. You're subtracting two whole number, answer should be whole number. You're multiplying, you're dividing, you're doing anything to those two whole numbers, you should get the whole number only. So for whole numbers, only addition and multiplication will follow the closure law. Subtraction and division does not follow the closure property. Is this clear?
Yes, ma'am.
Okay, then we came to integers. So for integers, we studied that again. What is our law? Closure law states that if you have two integers, so answer should be an integer only, whether you are adding, subtracting, multiplying or dividing. Whatever you are doing, your answer should be integer only. So we studied that for addition, subtraction and multiplication, the integers follows the closure law, but for division it does not follow the closure law. Clear till here?
Yes, ma'am.
Any doubts you have, Pavan?
No, ma'am.
Okay, easy. Now
Yes, ma'am.
we come to rational numbers. So for rational numbers also we have the same thing. We have addition, subtraction, multiplication, and division. Okay. So again, if you have two rational numbers, let's suppose I have 1 by 2 plus 3 by 2. So when I add them, I get 4 by 2.
Yes, ma'am.
So all three are rational numbers only.
Yes,
So
ma'am.
even if I take any of the negative number, let's suppose I'm taking negative 4 by 5 and adding 2 by 5 to it. So what do I get? I get negative 2
Minus
by
2 by
5.
2.
So again, all are rational numbers only. So addition follows the closure property. Yes, it does follow. Now talking about subtraction. So for subtraction, I'm going to have again, let's take negative 7 by 2 and negative 3 by 2. So what do I get? Negative 10 by 2 I get. All are rational
Yes.
numbers. Then I have, let's suppose, positive 11 by 3 subtracted 9 by 3. So what do I have? 2.
10 by 3.
No, 11 minus 9 into
Oh, 2 by 3.
2 by 3 I have. So again, I have rational numbers only. So yes, this is also true. Okay, talking about multiplication now. I have, let's suppose, 1 by 2 multiplied with 3 by 4. So what does it give me? 1 into 3 is 3
3
only.
by 3 by 8.
Very good. 3 by 8. So 3 by 8 is also a rational number only.
Yes,
Let's
ma'am.
take one more example for negative number also. Let's suppose I have minus 2 by 5 multiplied with positive 1 by 2. So what do I have? 2 into 1 is minus 2 and 5 into 2 is 10 only. So negative 2 by 10. So yeah,
Yes,
it
ma'am.
also does follow. Yes. Okay, for division, let's suppose
Uh,
I have 1 by 3 by 2 divided from 2 by 1, 1 by 2. Okay, now if I have division, so what do I do? Remember one thing. Do not be confused with division. You remove the division sign, you put a multiplication sign, and you reciprocal the next number.
yes,
Three
ma'am.
steps. Now look very carefully. I said 3 steps. What are those 3 steps? You remove the division sign. So what do you have? A multiplication sign.
Yes, ma'am.
You reciprocal the next number. So
3
reciprocal,
by 2 into 2 by 1.
very good. It becomes into 2 by 1. And now you multiply the numbers.
6 by 2.
Right. Okay, so whenever you have division of rational numbers, remember 3 steps. Remove the division sign, put a multiplication sign, reciprocal the other number. Will you remember these 3 steps?
Yes, ma'am.
Very good. So it is it following the closure law?
Yes, ma'am.
Yes, it is. Okay. So it does follow the closure law. So for rational numbers, it's true for all. For integers, it's true for subtraction, addition, multiplication, and for whole numbers, it is only true for addition and multiplication. Is this thing clear to you, Pavan?
Yes, ma'am.
Okay. Any doubts still here?
No, ma'am.
Okay. So now I shall be sharing a small set of questions with you. Okay, I'll be sharing those
Okay.
questions on the screen and then you have to answer those questions to me. Okay, just give me
Okay,
two
ma'am.
minutes. By the time you can
Okay, ma'am.
revise this thing, whatever we have studied, then I'm sharing this on the screen. Okay, Pavan, do you see the PDF on the screen? You see the PDF on the screen?
Yes, ma'am.
Okay. So, Pavan, you have some set of questions over here, and you have to solve these questions. Okay, so I'll be reading the questions for you. You can take out a pencil and a paper if you want, and you can just answer me directly. Okay, if you know the answer,
Okay,
just
ma'am.
tell me the answer. So, first question is write down a pair of integers whose sum is -7. So, you have to tell me two integers. On adding those integers, you should get -7. You understood the
Okay,
question?
ma'am. Yes, ma'am.
So, tell me the answer for this.
Okay, ma'am. 1 plus -8.
1 plus
No,
-6.
no, ma'am. No,
No problem, it's okay. You can do it easy. Take your time.
okay, ma'am. Ma'am, can you erase the first one?
Can I erase the
Can
first
you
one?
erase?
Okay.
Okay, ma'am. 1 minute. Ma'am, 1 plus -8.
1 plus -8.
Yes, ma'am.
Okay, good. That's
Second.
correct. 1 plus -8 would give you -7. Okay. Next you have is evaluate. So you have to solve this thing.
Ma'am, it said a pair of Oh, okay. I thought we had to write two.
No, no, that's fine. Pair means two numbers is one
Okay,
pair.
ma'am.
Okay.
Okay, ma'am.
Yeah. Then evaluate -6 plus 5 divided with -2 plus 1. So you have to solve the first thing, then you have to solve the second thing, and then you have to divide.
Okay, ma'am. Ma'am, 1. Is the answer 1?
Yeah. So -6 plus 5 should give you -1. And divided
Um,
with -2 plus 1 gives you -1. So -1
yes,
divided with -1 gives you +1.
yes, ma'am.
Good. Your answer is correct. Next is question 3. So the question says there's a girl named Ritu, and Ritu ate 3 by 5 part of an apple, and the remaining apple was eaten by her brother Somu. So what part of the apple did Somu eat? So there's one apple. From that one apple, 3 by 5 part was eaten by Ritu, and the remaining part was eaten by Somu. So you have to first tell that how much part was eaten by Somu. And once you've told,
So
yes,
Somu ate 2/5 of the part of the apple,
okay,
and Ritu had the larger share. She had it by 1/5.
very good. Larger share is 3 by 5 by Ritu, and by how much? By 1 by 5.
By 1/5.
Very good. Then question number 4, you have the enrollment in a school for 6 consecutive years was as follows. 1 second.
Hmm. Demo.
Yeah. Pavan, so the question is the enrollment in a school for 6 consecutive years was as follows. Like in the first year, how many students were enrolled? 1,555 students. Then 1,670 students. Then 1,750 students. Then 2,013 students. 2,540 students. Finally, 2,820 students. So you have to calculate what is the mean enrollment of the school for this period. So that means you have to calculate mean. Mean is, do you remember mean, median, mode? That
Sum of all observations by number of observations.
very good. You have to find the sum of all observation divided by the number of observations. So please divide it and tell me the answer.
Okay.
Yes, Pavan, have you completed?
1 minute. Ma'am, is it 2058?
2058. Let's check. So you have 1555 plus 1670 plus 1750 plus 2013 2540 plus 2820. So first you add.
Ma'am, 1, 2, 3, 4, 8.
Where?
Like everything, like the total sum.
Okay. Let's check. We're doing. Then you have 8, 9, 10, 15, 20, 26, 33. Then you have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 8. Okay. And how many numbers are there? There's 1, 2, 3,
1, 2,
4,
3,
5,
4, 8 by 6.
6. Okay. So 6 2 times, then 6 5 times, and then 6 8 times. So 2058. You're getting the change
Yes.
2058. So, correct. Then question number 5 is you have to solve the following equation by trial and error method. So what is the trial and error method, Pavan? You know?
Um, we have to assume P as like 1 or
Yeah,
2.
very good.
Like
You have
we have
to assume P as like is it 1, 0, 2, 3. Okay. And then you have to find the
to.
value. So you can
Okay,
just
ma'am.
look at the equation, try to assume a specific value. Just check for 2, 3 values and you'll get your answer. Okay.
Okay, ma'am. 1 minute. Ma'am, P is equal to 3.
P is equals to 3. Okay, that's correct. So let's also check. So we have like 5 multiplied with 3 plus 2 should give you 17. So we're getting 15 plus 2 is giving us 17. Yes, 17 is equals to 17. So that's correct.
Okay,
Okay.
ma'am.
Now next you have is question number 6, which says find the value of the unknown x in the following diagrams. So you have a diagram
Okay,
with
ma'am.
you and you have to find the value of x. Can you do this?
Yes, ma'am.
One second. Okay. Can you do this question?
Ma'am, x is equal to 30, 2x is equal to 60.
Yeah, let's check. So what we have in a triangle, the angles and properties, sum of all angles is 180 degrees. So what are the angles? 2x, x, and 90. So on adding them, you should get 180 degree. So 2x plus
Yes,
x
ma'am.
is 3x plus 90 should give you 180 degree. Now 3x should give you 180 minus 90. So x should
Is
be
equal
equal
to
to
90.
30 degree. Very good. So if x is
And
30,
2x is equal to 90. I mean,
60.
60.
Very good. So that is also correct. Very good, Pavan. You're doing all the answers correctly. So next question you have question 7, which says using laws of exponents, you have to simplify and write the answer in the exponential form. Okay, so please do question 7. You understood the question?
Yes, ma'am, is the answer 3 to the power of 14?
3 to the power 14. Okay, how? Can you tell me the method?
Uh, is it 3 3 to the power of 2 plus 4 plus 8 is equal to 3 to the power of 6 plus 8 is equal to 3 to the power of 14.
Okay, good. So what we do in the law, what is the law of exponent used over here? That when you have two numbers with the same base and different powers, so you add the powers. Okay, that means if you have a to the power n, a to the x plus into a to the power y. So what you do, you add a to the power x
A
plus.
to the power of x plus y.
So this is what you do. So you are going to write 3 to the power 2 plus 4 plus 8. That gives you 3 to the power 14. That's correct. Okay, question 8. Do question 8.
Yes, ma'am. Ma'am, minus 14 by 13. The first part.
Minus 14 by 13. Okay, how do you get it? So first you have is
Uh, the minus 2 by 13 divided by 1 by 7. So we have to make it to minus 2 by 13 into 7 by 1 is
yeah, I
equal
taught you
to
also.
minus 14 by 13.
Good. That's correct. Next.
1 minute. Ma'am, minus 3 by 10.
Minus 3 by 10. So you have minus 3 by 5 divided by, so 1 by 2. That gives you minus 3 by 10. Okay, good. Next is question 9. You have to evaluate this problem.
Okay.
Okay. Yes, Pavan, have you done?
Yes, ma'am. 509 by 60.
509 by 60. Let's check. So first of all, you have 23 by 4 plus 12 by 5 plus 1 by 3. So what do? You take the LCM first of all, right? That means you have to
Yes, ma'am.
make the denominator similar. So for 4, 5 and 3, what's the LCM?
60.
60. So you make the numbers similar. So 60 is the LCM. First you divide 4 and 60, what do you get? 15. So you
Uh,
have to multiply 15 by
yes, ma'am.
23.
Yes, ma'am.
You get 345
Yes, ma'am.
plus. Then 12 into 12 will be 144 plus
One for
20.
20.
Okay. So 345 plus 144 plus 20.
509.
509 by 60. What answer are you getting?
509 by 60.
Same answer. Good.
Yes, ma'am.
So that's correct. Okay, now you have question 10. You have to fill in the blanks. Like 9 plus minus 4 and minus 9 minus 4. So you have to solve first this thing. Then you have to solve first this thing. And then you have to compare the numbers. That whatever number are you getting, are they, which one is greater than equal to, okay, like that you have to compare.
Okay. Ma'am, it's option C or option A.
Okay, so what does the question say? The question says 9 it's 9 plus minus 4 and you have to compare with minus 9 minus 4. So 9 plus minus 4 is plus 5 and minus 9 minus plus 4. This gives you minus 5.
Minus 5. So
So
plus 5 is greater.
plus 5 is greater. So tell me, is it option A or C? One you have to tell.
Option A.
A is correct. Okay, not C. Because C says equal to greater than. That's not, no, that's not there in your syllabus. You can just eliminate these options. Option A is correct.
Okay, ma'am.
Okay, clear? Very good, Pavan.
Yes,
You
ma'am.
were able to solve all the questions very nicely. Very nicely done. So,
Thank you, ma'am.
yeah. So this was just a diagnostic test, just an evaluation basis. So whatever I taught you in today's class, was everything clear to you for rational numbers, whatever we studied?
Yes, ma'am.
Any doubts you have?
No, ma'am.
Okay. So I shall be sharing 1 or 2 questions for you as your homework. That homework will be visible to you on the Learnivio portal.